Dear students, very good morning. Today we are going to discuss about an important topic called partial derivatives. Partial derivatives. So under this topic, what is mean partial derivatives? Suppose we are having z equal to f of x comma y. Suppose we are having z equal to f of x comma y, then the given function can be differentiated with respect to x and y, because we are having two independent variables x and y. So the function can be differentiated with respect to both x and y. Here z is the function of two independent variables x and y. So we get dou z by dou x, and also dou z by dou y. Why we are using this dou means this is the partial differential operator. Because when we are using suppose if we are taking z is the function of x alone, then we will have dz by dx, because z is a function of x alone, so it can be differentiated with respect to x alone, so we can use d. So this d is the differential operator, whereas this dou is the partial differential operator. So it can be also denoted as for example, this partial differentiation of z with respect to x can also be mentioned as capital D. Okay, capital D, and with respect to x, the given function f, and this can be written as the partial differentiation of the function f with respect to y, that is dyf and dfx. So these are the two things that we have to know and we have to write very carefully. So and in this we are having a definition, that is the derivative of z with respect to x, treating x as the variable and y as constant, is the partial derivative of z with respect to x. In the same way, the partial derivative of the function treating y as variable and x as constant is given by the partial derivative of z with respect to y. So that is, these two definitions are very, very important. Now what will be the dou z by dou x? What will be dou z by dou x? So dou z by dou x is nothing but the limit delta x. Since I am differentiating partial with respect to x, there will be very, very small change. The delta x tends to 0, limit delta x tends to 0, f of x plus delta x comma y, f of x plus delta x comma y minus f of x comma y, f of x comma y divided by delta x. So this is the definition for this partial differential operator dou for the function z with respect to x. So this is definition of partial differentiation of z with respect to x, and in this we are having some notations. There are some notations, and those notations are denoted by p, q, then r, s and t. So p means it is dou z by dou x. P means dou z by dou x, that is partial differentiation of z with respect to x. Q means partial differentiation of z with respect to y, partial differentiation of z with respect to y. R means this is second order partial derivative, that is dou square z divided by dou square z divided by dou square z divided by dou x square, that is you are differentiating again p with respect to x, and s means differentiating x with respect to y, it is dou square z divided by dou x dou y, and t means dou square z by dou y square, dou square z by dou y square. So here important thing is this, so that we have to make as a note. So here it means, what does this mean? This means dou by dou x of dou z by dou y. So first thing is we are differentiating z with respect to y, and after that we are differentiating the result with respect to x. So this is first step, and this is the second step. So first we are differentiating with respect to y, and again we are differentiating with respect to x. So what will happen when I first differentiate this z with respect to x and then with respect to y? So if I first differentiate this with respect to x and then with respect to y, means it will become dou by dou y of dou z by dou x, dou z by dou x. So this is the another step, that is here I am first differentiating z with respect to x, and then I am differentiating the result with respect to y. So this will give the result as dou square z divided by dou y dou x. We have already dou square z by dou square z divided by dou x dou y. So whether these two are equal or not. So the important note is these two are equal under some certain conditions. So now we have seen what is partial derivative. Partial derivative means it is a differentiation when there are two or more independent variables involved in a function. So when a function can be written as function of two or more independent variables, there it is not possible to differentiate ordinarily, so we are using partial differentiation. So the partial differential operator is denoted by dou, and it is nothing but dou z by dou x and dou z by dou y. When z is differentiated with respect to x, partially we write dou z by dou x. When z is differentiated with respect to y, we write it as dou z by dou y. And here we can also know that dou z by dou x is nothing but limit delta x tends to 0 f of x plus delta x comma y minus f of x comma y divided by delta x. In the same way, when we want to write dou z by dou y means here limit delta y, instead of x it will become limit delta y tends to 0, f of x will be f of x alone, comma y plus delta y minus f of x comma y divided by delta y. So the definition is f of x comma y plus delta y minus f of x comma y divided by delta y. So this is the definition of dou z by dou x and dou z by dou y. Also here there are some notations, that is p equal to dou z by dou x, q equal to dou z by dou y, r equal to dou square z by dou x square, s equal to dou square z by dou x dou y, t equal to dou square z by dou y square. So here dou square z by dou x dou y equal to dou square z by dou y dou x under some certain conditions. Here dou square z by dou x dou y means first we are differentiating z with respect to y and then with respect to x. In the same way, dou square z by dou y dou x means first we are differentiating z with respect to x and then with respect to y. So here dou square z by dou x square means, so we are having p, that is dou z by dou x, that is again differentiated with respect to x, and dou square z by dou y square means here we are having y, that is dou z by dou y. So again we are differentiating this q partially with respect to y, so we get dou square z by dou y square. So this is the basic fundamental concept of partial derivative, and these notations are obtained when we are using successive partial differentiation. Since here we are having z as the function of both x and y, each notations can be written as f. So this can be written as f x. So p is nothing but fx, q is nothing but f y, r is nothing but f x x, s is nothing but f x y, t is nothing but f y y. So this type of step by step procedures in partial differentiation is called successive partial differentiation. Successive partial differentiation. I hope this small introduction to partial derivatives was useful to you. So in the next class we shall discuss a problem to this partial derivatives.